Hello guys, so in this example we're going to go over how to find the distance from a point to a plane, and basically the underlying concept is to just identify what your plane is, which is this equation right here. Identify what your distance is, or what your point is, sorry, which is this right here, and then we plug them into this formula that we see. A times x naught plus b times y naught plus c times z naught plus d is equal to the square root of uppercase A squared plus uppercase B squared plus uppercase C squared. So without further ado, we identify A, B, and C. And in doing so, we basically just ask ourselves whatever coefficient is with x is our A, whatever coefficient is with y is our B, whatever coefficient is with z is our C, and then whatever coefficient is remaining, which I will add, will be lowercase d. So in this case, our A, B, I can do a better job, B, C, and D. So our D, being our coefficient, will be 10. The coefficient of x is 3, so that'll be our A. The coefficient of y is minus 5, because keep in mind that we do care about sign convention as well. So this will be minus 5. The coefficient on z is 2. So now we have those identified. And then the next step would be to identify x naught, y naught, and z naught. So if I'm going to put a P right here for point. So in doing so, when we identify our x naught, y naught, and z naught, we basically just look at whatever our point is. So our x naught is equal to minus 1, y naught is equal to 2, z naught is equal to 5. So now that we have all the variables that we need, the next step in this would be to just plug them all into this formula. So the formula for distance is between a point to a plane is this right here. So we're going to go ahead and just write it down again. So our D is equal to A times x naught plus B times y naught plus C times z naught plus D. Then I put these bars, plus D, to indicate magnitude, divided by A squared plus B squared plus C squared. Or not magnitude, I meant to say absolute value inside a square root. So then our final step would be to just plug them in. To plug into formula. So in doing so, we plug in these variables down here. So A times x naught, so 3 times minus 1. So I'm going to go ahead and write it down here. And then B times y naught, so plus B, which is minus 5, times y naught, which is 2, plus C times z naught, so 2 times 5, plus whatever our D is, so plus 10. And all this, because it's in distance, will have an absolute value. So I put 1 bar around it. And then I'm going to set this equal to capital D. And then we divide by the magnitude of A squared plus B squared plus C squared. So our A is 3, our B is minus 5, and our C is 2. So 3 squared plus minus 5 squared plus 2 squared. I guess I'll put parentheses around this one as well. Then we take the square root of this. And whenever we punch this number in our calculator, our answer comes out to be, let's see, minus 10 plus 10. These cancel each other out. Plus 10 minus 3 is my 7. Divided by 25 plus 4 plus 9 is 25 plus 13, so the square root of 38. And if you want to rationalize this, you can. But just keep in mind that if this answer on the top were to come out negative, you have the absolute value sign because it's in distance, so distance can only be positive. So that's basically how you find the distance between a point and a plane. So identify your ABC coefficients and your D as well. Identify your point, x naught, y naught, z naught, and then you plug them into this formula right here, which is what we did over here. And then we got our distance between this point to this plane is 7 divided by the square root of 38. I hope that was helpful. Thank you for watching. Hello guys. So in this example, we're going to go over how to find the distance between a point to a plane. And basically, we do this whenever we're asked to, whenever we're given a point in a plane. And this is our formula right here. Is a times x naught plus b times y naught plus c times z naught plus d divided by the square root of a squared plus b squared plus c squared. So now without further ado, the first step is to identify our a, b, c, and lowercase d. Why lowercase? Because d, capital D is for distance, and lowercase d is for whatever is the coefficient, whatever constant you have for your plane. So without further ado, we're going to go ahead and identify these 4 variables. So a is whatever is on your x. So in this case, a is equal to 10. B is whatever is on your y. So in this case, y is equal to minus 1. Keep track of the negative sign as well. C is whatever's on your z. So in this case, c is equal to plus 2. And then d is whatever constant is in your plane. So in this case, d would be equal to negative 9. So now we have our a, b, c, and d. So now the next step is to identify x naught, y naught, and z naught. And I'm going to put p right here because it's for point. So basically we're just identifying the x, y, and z components of our point. So our x naught would be equal to 1. Our y naught is equal to 4. Our z naught is equal to minus 6. So now we have identified all our variables. So the next step of this process would be to plug them into the formula. So that's exactly what we're going to go ahead and do. So with this formula, we're going to go ahead and write it down. D is equal to a times x naught plus b times y naught plus c times z naught plus d. And I put this bar right here to indicate absolute value divided by a squared plus b squared plus c squared inside a square root. Alright, so now that we have the formula, without further ado, the next step would be to plug these in. So we're going to plug these variables into formula. So our D is equal to There we go. Now we can see everything. So our D is equal to A times X naught. So 10 times 1 plus B times Y naught. So B is minus 1, Y naught is 4. So minus 1 times 4 plus C times Z naught. So C is Z naught. So 2 times minus 6 plus our D. And our D in this case is minus 9. So in all this, I put absolute value. So that way our distance can only be in the positive. It cannot be negative distance. Negative distance just means that it's the same distance it's a positive distance in the opposite direction. So now we plug in the denominator. So a squared plus b squared plus c squared. So our a squared is equal to 10 squared plus our b squared is equal to minus 1 squared. And our c is equal to 2 squared. And then we plug this all inside a square root. And then whenever we plug this in, we get our d is equal to 10 minus 9. You can use a calculator, you can try to do it by hand. Either method works. 1 minus 4 is minus 3. Minus 3 minus 12 is minus 15. But we have absolute value divided by 10 squared plus 1 squared plus 4 squared. So it's the square root of 105. And this answer comes out to be 15 divided by the square root of 105. And if you want to radicalize this a step further, you can. I'm not going to, because I think the purpose was served. So basically, in retrospect, identify your A, B, C, and D, the coefficients of your plane equation, and your constant of your plane equation would be A, B, C, and D. And then the next step is to identify X naught, Y naught, and Z naught, which is basically what's given to you as a point right here. And then after that, you just plug them into the formula. And that's how you find distance between a point and a plane. Thank you for watching. I hope that was helpful.